Hi everyone. We are going to move on to the next topic, which is feature engineering. Feature engineering is kind of a weird topic because, well, almost everyone would agree that feature engineering is very important, and yet it's hard to find a good textbook which has a comprehensive discussion of the feature engineering. One of the reasons could be feature engineering just has so many different things, and I'm going to use one lecture to cover the important things I believe you should know. Okay, there are really a lot of the things for a data science project. Say if you have to select the right models, it's never a good idea that you try all the models on a data set and then select the best one. You have to first understand the problem. Say, is that a supervised or a unsupervised problem? And if it is supervised, is that a classification or is that a prediction? So what's the difference between them? What's the difference between the classification and prediction? So for the classification, we are classifying the class labels, and for the prediction, we are predicting the real values, right? Okay, and also you want to consider the size of the data, and if the data is too large, and then probably you want to only sample a small portion of that, and especially when you are doing the SVM struggles a lot with the large data set, and what is really large, and it really depends on your machine. And usually if I'm running SVM with thousands of data, usually there's no problem. But with a higher number, and I would like to sample a part of the dataset. And another condition is, what if your dataset is very small, or one class is very large and another class is really small? And then, remember we have two tools, bagging and pasting, right? So one is to deal with the large data set to sample it down a little bit, and another one is, we can pick the same samples several times. So we can actually pick the samples in the smaller class several times to make the data set a little bit larger and then make it more balanced. Okay, and then another thing you have to consider is, who are you reporting to? Well, if you're reporting to some person who has no background, and yet you are worrying that they may ask you a lot of the detailed questions on the technicals, and you may want to pick a white box model. So a model that you can easily explain to the people without the related data science background. And the last thing is, use your domain knowledge and your intuition as well. So, those are the things that you have to develop in the process of doing different projects. Okay, and when we decided the model we are going to do, and the next thing, we have to tune our models. There are quite a lot of the machine learning models. They require you to give parameters, and sometimes even a lot of the parameters, and you have to learn how those parameters work, or what do they really mean, in order to do that. And before that, remember, you can do the EDA, exploratory data analysis, and that is, you can get some sense of the data before you even dive into the further, like picking the model or training the model. And to tune the parameters, and then you should also use the able function. For example, for the k-nearest neighbor, we talk about the able function, and we have to try different k values. And then uh, excuse me, when you have a machine learning model, you need to tune several hyperparameters together, and then you usually want to use the grid search to find the good combination. And the last thing, remember, you can ask the domain person, and asking the domain person actually can save you a lot of time. And I can give you an example that when I did a spatial temporal data mining project, and we we struggled a lot in figuring out what are the good features. And so I just asked the domain person, if you have to guess, what are the good features in your dataset? And then he sent me two features. And then I throw away all the remaining features. Probably I throw away dozens of them. And then I only keep the two of them. And actually, with only those two features, then the model is already good enough. And this means I also throw away the x and y coordinates. Well, the point is, the x and y coordinates, or the latitude and the longitude, in that problem, they don't mean anything, or I can say they're not important at all. And then the domain person told me those two features, and they are indeed the most important two features. Okay, so the next question I want to discuss is, if you have a machine learning model, and if you have done all those steps, and you have the performance of the model, but this is not perfect, and then what do you do? How do you improve your model? And of course, one of the things is you can try different machine learning models, and there are some problems can be better solved in one machine learning model than other machine learning models. So trying different machine learning models can be one way. But if you decided that this is the right machine learning model, however, you are not quite impressed with the result, and that the next thing you can try is you can do some feature engineering. Okay, and actually feature engineering is the part we have already have seen several times. So for example, do you guys still remember PCA? I think we have a guest lecture show you guys a little bit of the PCA, right? And another thing is when we try to pick the top two features, and then we evaluated the important features, and then we pick the two of them, right? So that is the recursive feature elimination, and we are going to see that again. Okay, so the first part we are going to do is, there is a a function built in the scikit-learn called select k-best. So this is just to you need to send another function saying how those features are going to be evaluated, and then we are using the chi-square. Okay, so we have to load the dataset, and this is a diabetes dataset, and there are like a total of a total of 8 features, and then the last one is a class label. And as you can see, for all the features, they are numerical features, and the last one, class, it is just 0 or 1, right? So we separate the dataset into x and y. And after that, we want to use the select k-best, and then score function is to specify what function are we going to use to evaluate those features. And again, you want to use the fit. This is one of the things I like about the scikit-learn, because the syntax is quite consistent. And even though this is not quite a machine learning model, we are still doing the model dot fit, and then with the x and y, and then it will tell and then we have the select k best features trained. Okay, and the next thing, I want to specify the number of the digits of the precisions. I don't want to see a lot of digits after the decimal. And after that, you can do the fit.scores, and those are the scores of the features, and then they correspond to the feature names. Okay, so this is the preg, and then this is the score, and then plus, that's the score. Okay, so to make it a little bit easier to read, and I just dip those two things together, and then I make a dictionary. So now, for each of the features, there are the keys, and then for the scores of the feature importance, and there are the values. Okay, and the next thing we can do is, after we do the fit, so remember that fit is this one. So this is a trained k-best features, and then we are going to use the fit to do a transform. So after doing the transform of the X, and then we only keep the top 4 features. Okay, so because when we build the model, we say K is 4. So this select K best is trained to pick the top 4 features, and then it can uh, uh, transform the data and then only keep the top 4 features for you. Okay, so in the next one, we are going to do a comparison. We are going to see if we use the original dataset and what is the result of our predictive model, and then if we use the transformed features, so we only pick the top 4 features, and then what's the result of the same machine learning model. Okay, so we do the train test split, and then we are keeping the 30% of the dataset, and then we use the logistic regression. We do the training, and then we do the prediction, and this is the confusion matrix. Okay, so and then the next one, we have to use the selected features, because that is a data set with only 4 features, and after that, this is the same logistic regression model, and then I do the prediction, and this is my confusion matrix. So the point here is, well, just now we throw away 4 features, and we only keep the 4 good ones, and we throw 4 worse ones. Okay, and then after that, if you compare the performance of those 2 models, then you may find this one is actually a little bit better. Okay, so this is a trick you can definitely do if you want to improve your the performance of the model a little bit. Go ahead and then try to evaluate the features, and you can keep well, the top end of them, and then usually you can keep keep the same performance, or the performance of your model may even improve a little bit. Okay, so that's it, and I will see you in the next video.